Hi, welcome to Academic Math. In this video, I will solve question number 3 of exercise 2 of the book Higher Algebra. Of the book Higher Algebra by S.K. Mapa. Question number 3. There are two questions of question number 3, that is 3a and 3b. And 3a is given by a relation rho defined on Z, that is rho is a relation on Z. Rho is a relation on Z given by, and which is given by rho equals ordered pair AB belongs to Z by Z such that 3a plus 4b such that 7 divides 3a plus 4b, that is 3a plus 4b is a multiple of 7, we can say that. Now we have to check that is rho an equivalent relation or not. Our question is rho an equivalence relation or not, this is our question. Now to check that rho is an equivalence relation, first I will check that rho is reflexive or not. For a belongs to Z, we have the ordered pair a comma a is also belongs to Z cross Z. Now as 7 divides 3a plus 4a, that is this is totally equals to 7 divides 7a, as 7 divides 7a, and this is totally equal to 7a. 3a and 4a are two symmetric terms, and therefore we can add them, and 7 divides 7a, we can conclude that the ordered pair AB belongs to rho also. For all a belongs to any arbitrary a belongs to Z, this is true, which implies that rho is reflexive. Now our target is rho is symmetric or not, that is if AB belongs to rho, BA is also in rho or not. Let an ordered pair AB belongs to rho, which implies that 7 divides 3a plus 4b, which implies that 3a plus 4b equals 7 into k for some k not equal to 0. For some k not equal to 0 and belongs to Z, this will exist some k, and 7 divides this, therefore we can conclude that this is a multiple of 7, and there exists some k in Z for which it will satisfy. Now we will check that is 7 divides, now we will check that is 7 divides 3b plus 4a. Now as 3b plus 4a can also be written as 7 minus 4 into b plus 7 minus 3 into a, 7 minus 3 into a, which equals 7b minus 4b plus 7a minus 3a, and which can be written as 7 into a plus b minus 3a plus 4b. and which equals 7 a plus b minus 7 into k from the previous here, that is from this equation, from the last equation that we have. This equation we have here that 3a plus 4b is equal to 7k, and use this 3a plus 4b, 3a, same thing here, we can replace this the 3a plus 4b by 7k, and finally we can get common that 7a plus b minus k, and which equals 7 into sum k1 for sum k1 belongs to z such that k1 equals a plus b minus k. It will exist because a belongs to z, b belongs to z, and k also belongs to z, and therefore their addition and subtractions are always an integer, and therefore it k1 is finally an integer and hence belongs to z. So we can conclude that conclude that 7 divides 3b plus 4a also, which implies that b comma a is also belongs to the relation row, that is AB, and arbitrary ordered pair AB belongs to row implies that the ordered pair BA is also belongs to row, which implies that row is symmetric. Row is symmetric. Now our target is, we will check row is transitive or not. Let an ordered pair AB and another ordered pair BC belongs to row, Now our question is the ordered pair AC belongs to row or not. To verify that, now we will find the answer of this question, that is AC belongs to row or not. If AC belongs to row, then we can say that row is transitive. If AC does not belongs to row, then we can say that a row is not a transitive relation, and therefore AB and BC belongs to row. We have already assumed that AB and BC belongs to row, and which implies that 7 divides 3a plus 4b and 7 divides 3b plus 4c also, which implies that 3a plus 4b will be equal to 7k dash, and 3b plus 4c will be equal to 7k1 dash for some k1 dash and k dash belongs to z. Now adding these two, we have these two last equation, we have 3a plus 7b plus 4c will be equals to 7k dash plus k1 dash, which implies that 3a plus 4c will be equal to 7 into k dash plus k1 dash minus b, which implies that 3a plus 4c is equal to 7k2, where k2 belongs to z such that K2 equals to K1 dash plus K dash minus B, and which implies that 7 divides 3A plus 4C, that is the ordered pair AC also belongs to the relation rho. Hence, we can conclude that for AB and BC belongs to rho implies that the ordered pair AC also belongs to rho, which implies that rho is transitive, and therefore rho is an equivalence relation on Z. As we have already seen that rho is reflexive and rho is symmetric, here we have rho is reflexive and in this page rho is symmetric, and in the last page we have already seen that rho is transitive. Hence, we can conclude that rho is an equivalence relation on Z. Now, we will solve the second question of, that is the question B of the question 3, part B of the question number 3, that is question number 3B. In this question, a relation rho on Z defined on Z given by rho equals the ordered pair of Z by Z. The ordered pair belongs to Z by Z such that mod of A minus B is less equals 3. Now the question is rho an equivalence relation or not? Is rho an equivalence relation or not? Equivalence relation or not? This is the question. Now, to check it is equivalence or not, we have to check that is rho reflexive or symmetric or transitive or not, reflexive, symmetric or transitive or not. Now, first, for every A belongs to Z, we have the ordered pair A comma A belongs to Z by Z, but the ordered pair A comma A belongs to Z by Z, that does not mean that the ordered pair A comma A will belongs to rho also. That is, which ordered pairs will satisfy this equation, which such ordered pairs satisfy this condition, they would belong to rho. Now, as A satisfies, we had already it is from the intuition we can say that A minus A, and which is 0, and 0 is always less than or equal to 3, and 0, the modulus of 0 is 0, and which is always less equal to 3, and therefore we can say that this ordered pair A comma A belongs to rho also, as A minus A, as the modulus of A minus A equals mod of 0, which equals 0, and which is less than or equal to 3, which implies that the ordered pair A comma A belongs to rho for all A belongs to Z. That is, for any arbitrary ordered pair A comma A belongs to rho for all A belongs to Z. which shows that which implies that rho is reflexive. Now we will check rho is symmetric or not. Let an ordered pair AB belongs to rho, which implies that mod of A minus B is less equals to 3, as we know that mod of B minus A equals mod of A minus B, and which is always less or equals 3. Therefore mod of A minus B less equals 3, it implies that mod of B minus A is also less equals to 3, and that is AB belongs to rho implies that the ordered pair BA belongs to rho, and which implies that rho is symmetric. Now we will check that relation rho is transitive or not. To check the transitivity, let two ordered pairs AB and BC belongs to rho, and which implies that modulus of A minus B is less equals 3 is less equals 3. Therefore we can write this, and by the definition of the relation, that is, it is given that if they belongs to rho, then we can say that the modulus of A minus B is less equals to 3, and modulus of B minus C is also less equals to 3, as modulus of A minus C equals modulus of A minus B plus B minus C, which is always less equals to modulus of A minus B plus modulus of B minus C, and which is again less or equals to 3 plus 3, and which equals to 6. That is, modulus of A minus C is less or equals to 6, but this does not less or equals to 3, as modulus of A minus C less equals to 6 does not implies that modulus of A minus C less equals to 3. Therefore we can conclude that therefore AB and BC belongs to rho does not implies that the ordered pair AC belongs to rho. Hence we can say that rho is not a transitive relation. Transitive relation. We can verify the transitivity by assuming AB C in Z such that, assuming ABC, for example, if we take A equals 5, if we take A equals to 5, B equals to 3, and C equals to 1, then we have modulus of A minus B equals modulus of 5 minus 3, which equals 2, and which is always less or equals to 3. This, and modulus of B minus C equals modulus of 3 minus 1 equals 2, and which is also less equals to 3, but modulus of A minus B plus modulus of B minus C modulus of A minus B plus modulus of B minus C equals 2 plus 2, and which equals 4, and which does not less or equals to 3. So we can conclude that as modulus of A minus C is less equals to this, and this does not less than or equals to 3, therefore we can say that rho is not a transitive relation. That is, rho is not a transitive relation. Therefore, rho is reflexive, rho is symmetric, but rho is not transitive. Rho is reflexive, rho is symmetric, but rho is not transitive. Therefore, rho is not an equivalence relation. Therefore, rho is not an equivalence relation. Thank you. In the next video, I will solve the following questions of this book. And the students are requested to make comments if any problems in emergency need to you. I am creating this type of videos sequentially and creating some playlist so that you can solve solve every problems of this book clearly, and I am helping you in this regards. Thank you. If it works and if it makes some help to you, please subscribe my channel. If you want to get the solution, you can contact me also through the WhatsApp using the number 8145217730. Thank you.